So enthalpies is heat at a constant pressure. So we have delta H, that's the change in enthalpy. And this is the measure of heat as a constant pressure. It's a delta, so it's a change, and change is always final minus initial, so your products are what we end with. So we take the sum of the enthalpies at the end minus the sum of the enthalpies at the beginning. Enthalpy and heat are almost the same thing, but they're only the same thing when you're at a constant pressure. So if you're not at a constant pressure, then enthalpy and heat are not the same. Enthalpy is a state function, which means it doesn't depend on path, where heat is not a state function, so it does depend on the path. We're going to deal with enthalpy level diagrams, and these are just diagrams that show like the activation energy and are simple diagrams, and they're not real hard to deal with, so we can figure out if something's exothermic or endothermic, what the activation energy is for the forward and the reverse reaction. So in an endothermic reaction, the enthalpies of the products is greater than the enthalpies of the reactant, so we have to go up in energy because the system took in energy. So this is an example of an endothermic process. It means that the reactants had more energy than the products. Sorry, the products had more energy than the reactions, so the reactants had to take in energy. Exothermic reactions are the reverse. The products have less energy than the reactants, so the reactants gave off energy. And there's important things to understand, like the activation energy. This is an energy needed for the reaction just to start. Once it's started, then it's going to proceed to completion. And when it's an exothermic reaction, the thermometer goes up because the surroundings, which would include the thermometer, are increased in energy. When we talk about enthalpies, it's important to talk about the situation at which it's happening. Normally what we deal with is around 1 atmosphere. Maybe it's a little bit more or less, but we don't have to worry about that. When we deal with solutions, we almost always want to deal with 1 molar solutions. Temperature is 25 degrees Celsius, which is 298 Kelvin. And remember, if it's an endothermic or an exothermic reaction, then energy is transferred. If it's exothermic, it goes from the system to the surroundings, and if it's endothermic, it's from the surroundings into the system. So we got the universe, which is everything, the surroundings in the system. If energy goes into the system, then it's called endothermic, and if it leaves the system, it's exothermic.